You're going to have a lot of practice today with using that method to fill electrons into different atoms. You may be wondering, why did we know this, or how did we figure this out? First thing is that people began running experiments, and there was evidence that showed us that, like, the 4s filled before the 3d, or that degenerate orbitals fill singly before pairing. So we have this experimental evidence, but then people also began making theoretical calculations, and when those two things were in sync with each other, that's when they began designing this method of how the electrons fill the atoms. Again, electrons are represented with either half up or full up and down arrows. We have three principles that guide how electrons fill the atom. The first principle is Aufbau, and what he said was something we've been alluding to this whole time. You fill the first energy level and you fill the S's first. Those are lower energy, they have no nodes. Then you fill the second energy level and you fill the S's, and then the P's, and then the D's, and then the third energy level. So it has to do with, you should start with the first level and then get into the second, and then the third and the fourth. Don't start at the second level, meaning you've got electrons out here but nothing in the middle. You need the electrons in the middle first. That's the Aufbau principle. It's kind of like the principle of any house, or I used to think of the B in there being building. So when you're building an atom, you build it from the ground up. Then there's the Polyexclusion Principle. And what Pauli says is that you can't have an electron in the same orbital that's the same direction, as long as if it's unexcited. Like atoms just sitting there. You can't have an up arrow and a second up arrow. They have to be opposites. First thing you can think about is it has to do with the spin, and electrons, it's really hard to explain it, but electrons have this spin. They're a spinning, not only are they moving the atom, but they themselves are a spinning charge. And if you are a spinning charge, you make a magnetic field. So they have to align so their magnetic fields aren't fighting against each other. So they have to align, spin up and spin down is what it's called. If you go back to the video, in this last video, if you want to understand more about electron spin, it is not necessary, but that's the video you would watch. The third principle is that Huns Rule. This is often called the bus rule, but if you get on a bus, you are more likely to fill an empty seat before pairing up with someone. So the electrons will pair, will fill like this. They won't fill like that. And they won't fill where everyone's like up. They won't do that either. They fill singly before they fill with pairs. And part of the reason is there's some repulsion and there's that spin issue. You have to make sure that one spin it falls opposite. So to get this second electron in here, again, repulsion, spin has to be correct. It's just a little bit more energy, and it's much easier for the electron just to go ahead and sit in a different seat, and that's what they do. So those are the three principles when you're drawing and when you're filling these. Ground state is when all the electrons are basically where you put them. And that's what we're going to be doing. They're all in order, and they fill the way that we've been talking about them filling with the periodic chart. Excited state is what we were talking about last time, when there was energy from someplace and the electron jumps. It has to be able to jump to a required orbit too, but it jumps up to a higher level, and it exists in that level for a minute. It's just that if you have a lot of electrons in an atom, they could all be jumping, like have enough energy and be jumping like continuously. So if you're putting electricity in, or you're adding like a huge energy source to an atom. So we're stating and talking about, for the rest of this time, ground state. These aren't ones that have electrons attached, energy attached to them of any form. They're just the most basic kind of atom. And we will be talking about something called a core versus a valence electron. The core electrons are basically all of the electrons that are closest to the nucleus. The valence electrons are the ones that just has 2 in there. The valence electrons are in the outermost energy area. So if you have like a few electrons on the outside, the red ones are the valence, and then the inside ones are the core electrons. Also, this column right here will have 1 valence electron. This column will have 2. This column will have 3, 4, 5, 6, 7, or 8 valence electrons. You'll see this more in chapter 4, so don't overly stress about how many valence electrons there will be. You will get that in a huge amount of quantity Next chapter. You also have another word you need to know. It's isoelectric, and what that means is the same number of electrons. So if neon has 10 electrons, and it does, if we want, and we know fluorine has 9 electrons, if we add an electron to fluorine, making it fluorine minus, then he has 10 electrons. Electrons, electrons. Now these two are isoelectric. That is what isoelectric means, same number of electrons. We also have paramagnetism and we have diamagnetism. So paramagnetic versus diamagnetic elements. So a paramagnetic element is when you have some unpaired electrons, and this is when all are paired. Oops, and this was supposed to be the picture representing it. So again, if you have some degenerate orbitals, so right here, this picture has some unpaired electrons, so paramagnetic. But if we do this, now there are no unpaired electrons, and that is diamagnetic. We've got some great videos from Dr. Bean in this idea of what paramagnetism and diamagnetism does and how it is affected by magnets. And again, this is the energy scale. This is, again, that's like the first orbital, and this is like the second orbital, and it's like the third, and then that's like the fourth. You see what I'm saying? And this is like your nucleus right there. Only they aren't really orbitals, right? They aren't really orbits. They're orbitals, which are shapes that are layered of increasing size on top of each other. So we're going to practice writing electron configuration using this. So we're going to begin with hydrogen. So hydrogen, that one's really easy. It's just 1s, and it only has 1 electron, so it's 1s1. Helium, on the periodic chart, you can look, he's got 2 electrons. He's 1s2. We don't write 1 and 2, we're just filling the s all the way. Lithium is 1 more over. We have 1s2, that's what hydrogen, the last electron of helium had. And now we're over here, so now we're at 2s1. Let's jump over to nitrogen. Notice these squares are showing where the elements are. 1s2, 2s. So there's 1 and 2. And then we have 1, 2, 3. So 2p3. This one got misplaced. This is where neon is, right here. So go ahead and you figure out these two sets right here.